Okay, lesson 13.2. We're going to be looking at angles, parallel lines, we're going to look at transversals, and even two lines that aren't parallel and the angle relationships among them. So first, to do a couple definitions, and this is on that paper so you don't have to copy down word for word. A transversal is a line that intersects two or more lines in a plane at different points, and it's called the transversal. Alright, so when you have two lines, remember we had two intersecting lines and we talked about the vertical angles. When you have two lines being intersected by one line, you are forming 8 angles. So here we go. Note the lines aren't parallel. Lines N and M are being intersected by line T. T would be the transversal. And you can see the angles that are formed. There's 8 of them. Different types of angles are formed. They're all listed here. Exterior angles, interior angles, consecutive interior angles, alternate exterior, and alternate interior. And we also have corresponding. So when we have parallel lines that are being intersected, we can tell the vertical angles, right? They're the opposite angles and they're equal or congruent. So in this case we have 1 equal to 4, 2 equal to 3, 5 equal to 8, and 6 equal to 7. And you also have the linear pairs, which are supplementary angles. They form a line. And those are all listed on your slide as well. So if you have parallel lines cut by a transversal, then you have congruent angles in your corresponding angles, your alternate interior, alternate exterior. If two parallel lines are cut by a transversal, then the following pairs are supplementary: the consecutive interior and consecutive exterior. And we're going to learn about all those placements and how to calculate. So basically, when parallel lines are intersected by a transversal, there's only 2 different angle degrees that are formed. One of them will be given to you. The other one you calculate by subtracting from 180 and then understanding the relationships and knowing which ones are equal to which ones. So when we're talking about corresponding angles, they occupy corresponding positions when the transversal cuts through it. So I'd say 1 and 5 would be maybe the upper left angles formed, and they are equal to each other. 3 and 7 are the lower left angles, equal to each other. 2 and 6, upper right, equal to each other. And 4 and 8, lower right, equal to each other. So these are all the angles that are equal to each other because they are corresponding and the lines are parallel. Okay, when we're talking about consecutive interior angles, they are 2 lines or 2 angles that lie between parallel lines on the same side as the transversal. So we can see we're talking interior, so inside the parallel lines, 3 and 5 and 4 and 6. 3 plus 5 equals 180 and 4 plus 6 equals 180. And then we also have the exterior angles. Same rule applies. When you add them together, they will equal 180. So 1 and 7 is 180, and 2 and 8, 180. The alternate interior angles, if the lines are parallel, are equal to each other. So 6 and 3 are equal to each other. 4 and 5 are equal to each other. They're congruent. The alternate exterior angles, they lie outside the parallel lines and opposite sides of the transversal, and they too are equal to each other or congruent. So here's an example. If line AB is parallel to line CD and S is parallel to T, find the measure of all angles when the measure of 1 is equal to 100 and justify your answers. So we start looking at these relationships between the lines, and you can see all the corresponding angles, all the alternate interior, alternate exterior, all the so the measure of angle 2 would be 80 because 100 plus 80 equals 180. Angle 3 is vertical to 1, therefore it's 100, and angle 4 is vertical to 2, so therefore it is 80. When you look at the measure of angle 5, it corresponds to 1 and is equal to 100 degrees, which makes 6 corresponding to 2 and 80 degrees. 7 is vertical to 5 and 8 is vertical to 6. The measure of angle 9 corresponds to 1 as well. So it's 100 degrees. 10 would be 80, 11 is vertical to 9, and 12 is vertical to 10. And finally, 13, which is corresponding to 9, would be 100, and then 14 would be 80, 15, 100, and 16, 80. In the next example, if line AB is parallel to line CD and S is parallel to T, let's find the value of X if the measure of angle 3 is 4x plus 6. So now we have something a little different. We have this angle being 4x plus 6, and the measure of angle 11 is 126. And all we need is the value of x. How are we going to find x in this case? What's true about angle 3 and angle 11? Yes, they're equal to each other. Therefore, we have the equation of 4x plus 6 equals 126. So we have 4x equals 120 and x equals 30. So I subtracted 6 from both sides. I divided by 4 on both sides. I know I'm gonna overlap. So 30 degrees for x. Okay. What is the value of x if measure of angle 1 is 100 and measure of angle 8 is 2x plus 10? We need to know the relationship between 1 and 8. Well, let's first talk about the relationship between 1 and 8. Yes?
They are opposite.
Okay. They're on the exterior, right?
Are they equal?
Are they equal to each other in this case?
No.
They're not. We call them consecutive, so they are supplementary. So in this,
80 left.
yeah, 2x plus 10 plus 100 equal 180. So,
30.
yes. And if we subtract 110 from both sides, and divide by 2, x is equal to 35 degrees. Okay, so it's understanding those relationships, and they are written down and defined on your slides. The final example with these lines. Find the value of y if m, measure of angle 11, is equal to 3y minus 5, and 16 is equal to 2y plus 20. What is true about these two angles? Well, we know that angle 12 and angle 11 are supplementary. right? So that they add up to be 180. And 12 and 16 are corresponding and equal to each other. So that means that 2y plus 20 plus 3y minus 5 must equal 180. And then we have some like terms to combine. So we'll get 5y plus 15 equals 180. So five y is equal to 165, and y is equal to 33 degrees.